as a reminder, you can access the schedule on the main website for this event. So this is a web page that I think we'll just continuously be referring back to. You can march through the days and kind of keep track of where we're at if you do lose track or have to sign off Zoom at any point. So we have a session planned today that's fairly brief, just designed to get people up to speed on the technology being used for this event. So I'm going to start off. I'm Scott Henderson. I'm a research scientist at the University of Washington in the Department of Earth and Space Sciences, and I also work in the eScience Institute. So for this particular event, I've been the lead of technology for putting together the computing infrastructure we're using, and have been involved in kind of putting together these events over the past several iterations. And each time we kind of improve upon things and try out new systems to work together, especially in light of working virtually versus working in person. So I just wanted to take a few minutes to provide some context in the systems that we're using this week. So from this webpage, at the very top, many of you have already navigated this website, and we've asked folks to kind of get familiar with it before, but no worries if this is the first time you've landed here. Just want to provide some guidance in how to navigate and get around. We're going to be using a Jupyter book that we've put together that consolidates a lot of the tutorial materials over the next few days. And this is linked at the very top of our main event webpage. So clicking on this blue button here will take you to another area within this website where some of you have already worked through a series of suggested preliminary work to get up to speed, setting up a GitHub account, connecting to Jupyter Hub infrastructure. Under this preliminary work section, you'll find various pages that you can go through at your own pace. You can always get back to that main schedule here on the left navigation bar. So clicking on schedule will take you back to where we were just looking. So I encourage people to navigate the site. We've consolidated a lot of interesting reference material. And again, please just navigate this at your own pace. What I want to demonstrate really quickly is accessing our common computational environment for this week. This is a Jupyter Hub, and the link here in this green section, we've just kind of put a convenient reference for you to get to this website. We're using a Jupyter Hub, which is a way to manage a set of servers on cloud computing infrastructure. And the reason we do this is so that we don't have to configure the computing environment, the software libraries required for tutorials on everyone's laptop. And it just really greatly facilitates collaboration working in a common environment. So that link from the Jupyter book takes you to this landing page. As Anthony mentioned earlier, 2i2c is a nonprofit organization we work with to set up computing infrastructure. And you can read more about their organization from this landing page. If you've already logged in before, you will probably be taken to this page. Some folks have already asked, which of these options are best. These are different options based on your computing resource needs. And this is another reason we like to use these server configurations on the cloud, is that as projects develop and you might need more computing resources than you need for simple tutorials, it's just a matter of selecting a larger machine that you can run on in this cloud data center. But for most cases, start small. So this is referring to a machine type in the Amazon Web Services data center, US West 2. And the second key reason that we use this infrastructure is that NASA is starting to host ICESat-2 data in this AWS Amazon Web Services US West 2 data center. So when we click on this button, small and start, what's happening is a machine is being configured for us with our computing environment and started up, booted up, and then we are plopped into it in a Jupyter notebook interface. So this takes a little while because this machine is being created. So this is a good thing to do kind of at the beginning of the day. Each day as we're getting started, just start up your server, brew a cup of coffee, answer an email. It generally takes just less than 5 minutes. If things are taking longer than 5 minutes, maybe there's an issue. Generally, it's about 5 minutes to start a machine. So this is a really unique opportunity, actually, to be able to start up a computational environment right next to where this ICESat-2 data is being hosted. And we'll get into that throughout the week, but this means that we can execute code without having to download necessarily massive amounts of ICESat-2 data over slow Wi-Fi or other internet connections. If you're unfamiliar with Jupyter Hub interfaces, it can be a little confusing because you're using your web browser to run code, and it's not very clear necessarily where that code is actually being run. In this case, our server is running in this AWS US2 data center, but we're just interacting with that server through our web browser. So that's kind of an overview of the infrastructure. You can get some updates here to see we've been spending a few minutes. We're waiting for more machines to be launched. So these are just informative kind of log messages as your machine's starting. I want to emphasize too that during this week, we're trying out new things, and it's totally normal to encounter errors. In fact, encouraged, I would say, or potentially things not working as expected. And the key is that we can troubleshoot together using Slack. So if you ever have questions about what's going on or not really understanding how things are configured, please do reach out on the Slack to ask those questions. I do want to go back to our website really quickly. And just point out that from our website here, there's a little icon at the upper right on every website page that links you to the source repository for this notebook. So if you click that, you're taken to our ICESat-2 GitHub organization. And all of this content we've put together is open and hosted in this particular repository. So we're going to be learning a lot about Git and GitHub and using GitHub. It's not necessary for collaboration, but it is very useful, and it provides a lot of fantastic collaboration tools that we can use as academic researchers for free. So we do a lot of work in these events using this GitHub organization as kind of an overarching umbrella. And again, this website is fully configured here through this repository. So this is still taking a while. That's fine. I'll leave you with kind of an image that I love from our last event over the summer from the SnowX Hackweek that I think speaks to this need for improvisation during these weeks. We all have things we want to accomplish during the week and goals we're trying to get to. But at the end of the day, it's about learning, trying new things, figuring out tricks to improve working together and accelerate our work together. But this is one particular hack from our summer when we were together last year, where the connection to the server wasn't staying active. And so a participant ended up just putting a nearby rock onto their spacebar to make things continue to run. I thought this was great. And basically it just shows, whatever works, go ahead and do it this week. and have some fun in the process. So please ask any questions on Slack. And with that, I'll turn it over to Dan Shapero to talk a bit more about GitHub and Git.
Hi, how's everyone doing? So I'm going to give just a bit of a preview of some of the things that we're going to be doing with Git and GitHub. So for those who are not familiar, Git is a version control system, and I'll share my screen to show you a bit about it. So I'm going to assume everyone here has already seen collaborative document editing tools like Google Docs and Dropbox. And what these are really good for is they help you sync documents that you're working on with other people, and they do it automatically, and they do it in real time. And that's really nice if you're working on a paper with someone. And it works pretty well for a couple of people. But where things start to become troublesome is where you have more people, let's say 5 that are working on it, or if you're working with just someone else, but you're both trying to work on, say, the exact same section of a document at the same time. So Git is a command line tool that fulfills a similar purpose. It helps you sync source code or other text documents between you and several other collaborators. But it kind of makes a few different trade-offs compared to what Google Docs and Dropbox do. Rather than sync documents automatically, you have to be very explicit about what you do want to sync. So for example, if I'm working on sharing a program that's split among several source code files, I might say that I only want to sync one of those files, not the others. But in return for this, so there's kind of more responsibility. There's a little more work that's put on you as part of this procedure, but you get very, very fine-grained control, which can be important when you're working on larger applications. And it also enables you to do branching, which is to try out different features and have those be on kind of separate workflows from other features. On top of that, there are a lot of services that are built around Git, which by itself is just a command line program. But there are websites like GitHub and GitLab or Bitbucket, and there are loads of others that will host these Git repositories for you. And by a repository, I just mean a collection of source code or documents that are kind of all in one package. And they provide all sorts of kind of nice things on top of just what Git, the command line program, does. So for example, they'll help you distribute that source code to other people. They'll help you test it automatically, which is really nice. So I just thought, for example, I would show you one thing on GitHub. So one thing that we're trying to Git by itself is a command line program, and GitHub is a website that is built on top of kind of providing services around it. And the two are sort of different things. So GitHub is built on top of it, but there are other services like GitLab or Bitbucket that also use it. So I'll just quickly search for IcePix, which is a software package that our very own Jessica Scheik develops. And one of the cool things that GitHub and other tools will do for you is they'll automatically run tests of your source code. So here, I noticed there's this little check mark in the user interface here. And when you click on that, it says all checks have passed, because Jessica Scheik is a good software engineer whom we should all seek to emulate. And here we can see the latest unit tests for IcePix. So there are a lot of things to know about Git, and this is sort of a challenging topic to teach, and a lot of people who are first exposed to it find it quite difficult, and that's totally okay. I had a lot of challenges with it when I was first learning to use it, and I've made just about every single mistake in the book there is, but at least for kind of introductory usage, there are really only 6 commands that are important about it. First is to fetch some source code or a repository of source code somewhere from the internet. Second is to check the state of that source code if you've made any changes to it. Next is to add or to stage files of that repository that, if you have changes that you've made, some of them you may want to decide to add back to the internet later. Once you've staged several changes, you can commit them where you say this kind of set of changes that I've made to this source repository are all going to go in one little ball of data that we'll give a name to, and that we're going to put a little message in that describes what it does. And finally, to push those changes to the internet and to pull other people's changes from that repository. So I just thought I would give a little brief demo of this. Just kind of showing the introductory workflow. You don't have to be following along with this on your own machine. You're going to have plenty of opportunities to practice this throughout the Hack Week. So I'm going to go back to GitHub, and I'm going to make a new repository. So one of the things I just wanted to point out here is they give you the option of making repositories public or private. So if you have stuff that you're not quite ready to share yet, you can start making it private and you can share it with people later. But I'm just going to make this public. And once I create it, I can never remember what any of these commands are. And helpfully, GitHub tells me what they are and what order I need to do them in. The first thing, so this will create a blank Git repository that lives on GitHub on this website. But on my own computer, I don't have it yet. So I'm going to clone it. And what this is going to do is it's going to go talk to GitHub and see if I have the right permissions to clone this source code, because if I made it private, I want to make sure that other people can't get at it, and then download it. So it's given me this warning that I've cloned an empty repository, and that's totally okay. That's exactly what I expected. So if I go into this example repo, the first thing I'm going to do is git status, and that's going to tell me what this repository looks like right now. And here we can see that it says there are no commits yet. So I'm going to make something. So I've opened up a text editor, and I'm going to make a little markdown document. So I've just written some placeholder text, and I'll exit out of my text editor. And so here, if you're on Mac, you might already have this extension in your terminal already, but it shows a little X here in the terminal to show that I have uncommitted changes or unstaged changes. That's sort of a little add-on that's kind of nice and helpful, but you can also see what the state of that repository is by doing git status. And it tells me that I'm on the main branch. I still haven't committed anything, but I have an untracked file, which is called readme.md. So for now, this file hasn't been staged yet. So again, the third command that I put on that list is to stage this file. And what this does is it says, so soon we're going to send this file off to the internet, off to this remote repository on GitHub. And I want to get it ready. So here, if I do git status again, I can see that now that I've done that command a second time, at first it showed it as an untracked file, and my terminal is helpful in printing it out in red. And now it says this changes to be committed. So when you're staging something, you might be staging more than one file. You might be staging changes in some files and not others. So there's the extra command that happens after this is called committing those changes. So to commit it, what it does is it says that all of these changes that are to be committed, we're going to package them together, and we're going to give them a message so that other people who look at this can tell what it was that I was doing. Now, the way to unpack this is git commit, and then -m says we're going to write the message describing that commit in one line. And the message that I'm adding is that I'm just adding a README file. It's important to write kind of clear and descriptive commit messages. So you might say, this is a little silly, but if you were fixing a bug in some code, you might want to say, oh, this fixes the problem we were having with endianness or the coordinate reference system or what have you. So it's going to spit out a bunch of cryptic things that I don't particularly care about. But if I do git status again, it's going to say that, again, I'm on the branch main, and now I don't have any changes to be committed because I've already done them. And it says my branch is based on origin main. Oh, well, that's a new one on me. Okay. And then when I push those changes, I can go back to GitHub and I can see that they're here now. So I'm going to go through this procedure again, just with another, just one more time. So I'll create a license. Really, I should be copying a big text that says, full text of that license. So here, again, I created a new file using my text editor. It shows up as untracked. I'm going to do git add to stage that file. Once I've added it, it now shows up as having gone from untracked to be committed. Now I can commit that file. If I do status again, I can see that my branch is ahead of the origin by 1 commit. And if I do git push again and go back, I can see that this license.md file has been added to the remote repository. There's one other kind of little helpful thing that you might use sometimes, which is git log. And this just shows me all the previous commits. So for most purposes, this is really all you're going to need. And here, I'll just show it to you. It's not going to do anything, but Git Pull will fetch changes that have happened on this remote repository that I don't have on my machine. Now, in this case, it's just me creating this repository and pushing changes. But if you're working with other people, they might be adding some new commits on that you'll then have to fetch. So sometimes this can create some problems if you, for example, try to push stuff, but you haven't fetched the latest ones. And we'll show you how to deal with all of that later. So I found this helpful graphic that kind of illustrates some of the stages here. So just to repeat this point again, when you clone a repository of source code, you have a version that's on your computer and you can make changes and you can make commits to it. And there's also a version that lives somewhere on some server on GitHub. And one of the responsibilities you have when you're using Git is to explicitly sync between your local copy and the remote copy. So this diagram here shows kind of some of the parts of this workflow that I just showed you before. Oh, whoopsie daisies. So if I just start with some changes that I've made to a file or a new file that I've added, when I use this git add command, it puts it into a staging area, which is some changes that I'm going to package into one commit and later send off to the remote. When I do git commit, it puts that whole kind of ball of changes, which might occur to several files, into one unit. And finally, git push sends it off to the internet. Git pull fetches it back from the internet. And if there's stuff about this that you still don't find clear, or if you want some more illustration, we're happy to talk about that more in any of the other sessions. So finally, just a few final notes about this. This is often, beginners can find it difficult, and that's totally okay. We all found it difficult when we were first learning to use it. And often if you're just learning to use it by yourself, it might be difficult to see the point. So some of you might have tried this already, but kind of it wasn't obvious why you were using this as opposed to something like Dropbox. Here in the projects that you're all going to break out into, when you're working with more than one people, I think you'll start to see why we're really a big fan of tools like this. So just a few other kind of little minor things. Writing good and clear commit messages is nice. You might remember what you did, but it helps to clue all of your collaborators into what you were doing. And a final thing is that Git is good for storing text. So the source code of, say, a Python script is all text, but it's not good at storing binary files. So images or movies or the big HDF5 files that we'll be downloading with some ICESat-2 data in them. And you'll also, probably a lot of you are going to be working with Jupyter notebooks, and you'll probably want to store those notebooks in version control. So it's a good idea when you're working with notebooks to restart them and always clear all of the outputs in them. You can always regenerate plots later. And if you're storing those in version control, then it'll help you keep only what's essential and nothing of what isn't. So hopefully, if you haven't seen Git at all before, this gives you at least some rough idea of kind of what are the steps you use, what are the steps you do to use it, and what it's good for. And I think that's it for me. And I was going to hand it over to Joachim.
All right. Thanks, Dan, for the intro. I'm going to like to take the last 10 minutes that we have allocated for this tutorial and also show you a graphical tool that we have on the Jupyter Hub installed to maybe also help you a little better to get into Git and use it a little more. So I'm going to start share my screen on this one. You all hopefully should see my browser now. So this is also the website that has the commands that Dan just listed to you sorted out. So if you go back to the Jupyter book that Scott showed you earlier, and you go to the tutorial section, under there on the first one, you see GitHub, Git and Jupyter Hub. This is another kind of laundry list that we made for you guys to show you a little overview, and also it's, look, you see these commands that Dan just used. And for the graphical part that I wanted to show you right now is once you're logged in to the hub, you see the bar here on the left-hand side. The first one you will have is the file browser. So this is basically your home directory, and you will see everything that you have as files inside the hub. And then there's the fourth tab down here, which shows you Git. And there, since we don't have anything there yet, it shows us a prompt what we want to do in terms of maybe creating some content. But I want to say, look, let's clone a repository. This is the first command that Dan showed you, git clone. And for this exercise, I want to just use the website, which is also going to be helpful for you guys because we're going to have all the tutorials within the website repository. So I go back to github.com, go to ICESat-2 website 2020. So let's go back a step maybe here. So if you land here on the ICESat-2 homepage for the organization, you go to the website 2022. And then up here, you see the green code button. And this is where you will find the URL that you need in order to clone the repository. It's right here, git clone. It gives us a nice little button, so I can just click and copy it. With that, I'm going to go over here and enter that exact same URL into the window. So I just pasted it inside here. And now it will do that git clone command that Dan just showed on the terminal, but it will do it for us here on the hub. So we will now copy or make a local copy in our hub for our own users. So you don't have to worry about like doing this for our own user. Everybody has his own separate space there. And now you see website 2022. It's like the same name as it has for the repository on your hub. So, and now we can start to navigate this website. If we go inside there first, and now we use the Git plugin now, you see it looks a little different. So now, as Dan had in his terminal, you see we're currently on the main branch, which is always the latest content that we are also publishing on the site. And it shows us again the name of the repository and those three areas that Dan showed us earlier. Untracked files right now, good. We have nothing untracked. We have no changes that need to be committed. So this is empty too. And you also have a staging area that's empty, meaning there's nothing yet that will be committed next time we would issue a git command. In order to make this a little more interesting right now, I'm inside the website repository. And for this exercise, for instance, here, I'm going to do the README, and I'm going to just add a new line. Important, you also have to save it now on the hub in order for these changes to show up, because only changes that are saved will be showing up in Git. So for that, you can do either use save here, but I'm just going to use Control S as a shortcut on my keyboard. So now if I go back to my Git, you see, look, I have changed the README. And so the README now has the line I added, as you can see right here. But if I double click right here now, you show diff this file. So now this little plugin should have shown me. I know why it doesn't right now. Let's try this again. Do a little diff this file. For some reason, it doesn't like to show up. But in theory, it should show it as there should be the diff in line. I know what it's doing right now, but this is how you can actually show what is something different from the time you changed to the last time you pulled. And now if I wanted to add that, like Dan did, to say, okay, I want to add this to my next area, to commit it, you have to do the plus sign right here. Stage this change, and you will see it will hop up over to the README. So now the README moved from changed to stage, and now we can enter what Dan did earlier, a little summary. So GitHub likes to separate the two messages you add to a commit into a header. It's like with every good chapter, it has a header that does an executive summary. And then you can do a long explanation as long as you want in there to make it a little more details to give someone that comes back to this change that hasn't seen it. Or also for you personally, for instance, if you come back to this change a year later and you don't know what to do there, I highly recommend you being very verbose. I oftentimes use it and came back to this like, this is what I did. So now it makes more sense. But anyhow, so now I'm going to do it actually for this website because, we don't want to change content. It's not necessary. But if I would do this now and commit it, this commit button down here would activate. And this is what then is able to be being pulled or pushed, so to say, to the remote. And for those, we have these two buttons up here. One is the pull. So now it will take down or get the latest changes. And the other one would be the push, which would push it up to the website or in the other repository that you might have cloned there. Is there anything else there? I think so far this should kind of give you a little bit kind of a start here, for instance, to follow with the tutorials that are gonna start tomorrow. I would highly encourage you, if you just want to follow along with the tutorials, to use this kind of visual representation of Git just to get the website going locally, and then you can kind of mess around a little bit with it. But again, like Dan said, Git is a phenomenal tool. It's also very, very complex. We all learned it over many years. And don't be afraid to ask any questions. There is no question that is too simple. We can all kind of learn from each other. And we all have learned from each other by asking these simple questions in order to get started here.